Good evening, everyone. Welcome to the last live interactive session of week 8 content. We'll just wait for a few minutes so that people can assemble. Good evening, everyone. Welcome to the last live interactive session for the course Nanotechnology in Agriculture. My name is Amey Dukle. I am Prime Minister Research Fellow in the Department of Mechanical Engineering, IIT Tirupati. The course instructor for this course is Professor Mainak Das, who is the professor in the Department of Biological Sciences and Bioengineering in IIT Kanpur. So, as always, a few basic guidelines. This session is not compulsory, but we highly encourage you to take part in it to boost your performance. I request you to be respectful in the chat. If you want to ask any doubt, you can unmute yourself and ask, or put in the chat box. It will, as always, the video will be uploaded on YouTube. So today's session plan is very simple. We have revised all the questions yesterday itself. So only week 8 content was remaining. So we'll be discussing week 8 content, and whatever important question and answers you have, we'll finish it. Maybe you can keep a list of all your question and answers. Um, we'll try to finish the assignment date as quickly as possible so that we can take your questions early. So let's start with the first question. Steric stabilization is usually imparted by dash. Example: cellulose derivatives, uh, polohexamers, polysorbates, or polyvidones, preventing particles from getting into the range of attractive van der Waals force. Non-ionic polymers and non-ionic surfactants, ionic polymers and non-ionic surfactants, ionic polymers and ionic surfactants, non-ionic polymers. So basically, what is stabilization? So basically, what happens is if the two nanoparticles come very close to each other, we all know that there is something called as van der Waals force that will start acting between them. What will happen due to that? That there will be agglomeration. And why we don't want agglomeration? Because it reduces the surface area by volume ratio of your nanoparticle, which in turn uh, gives less surface area for the nanoparticle to work on, and it reduces its efficacy. So that is why we need to have steric stabilization. So uh, what do you think will be the answer? The answer is non-ionic polymers and non-ionic surfactants. So obviously, if you have anything ionic, there will be some kind of charge distribution because of that ionic surfactant as well. So that will again create a mess. So that is why we always prefer non-ionic polymers and non-ionic surfactants. So this is how the a typical setup looks like. So this is a nanoparticle comes with because of the charge. So Yeah, yeah. Sorry for the issue. I'll repeat the questions. I think so there is some problem with my audio. I'll just repeat all the questions. So I think the first question was completed. So we'll move to the second question. Um, to prevent the toxic effect of gadolinium while keeping the dash properties, dash the gadolinium ion is chelated or encapsulated by a ligand chelator in form of entity called as a complex or a chelate. Diamagnetic properties, ferromagnetic properties, paramagnetic properties, soft magnetic properties. So the answer is paramagnetic properties. We already had studied last week that there are seven unpaired electrons pointing in the same direction uh, in gadolinium. So when the electrons are pointing in one direction, it is a paramagnetic material. So if the electrons are in like opposite direction, it becomes a, a diamagnetic. So one direction it is paramagnetic, in both the direction it is diamagnetic. So the answer is paramagnetic. The question number three, in drug industry, the commonly used steric stabilizers include hydroxypropyl methyl cellulose, hydroxypropyl cellulose, polyvinyl pyrrolidine, or povidone, methyl cellulose, hydroxymethyl ethyl cellulose, uh, or HPMC, HPC, PVP, methyl cellulose, MC, and AIGC. So the answer is basically all of the above. So this is a GK type of question. If you actually look at various drug, what do you say, drug on their labels, you will find these names. So if it is a like an I kind of thing, then it will be a methyl cellulose or a PVP. If it is something which has to be ingested inside the body, there is a good chance it will be a PVP. For like depending on whatever application which you are doing. So different kind of stabilizers are used. So moving to question number four, dash are the compounds that lower the surface tension or interfacial tension and enable the proper wetting of drug particles with suspension, liquid, usually water, stabilizers, surfactants, gelling agents, milling agents. So basically, what is surface tension? So basically, surface tension is that the cohesive force between the liquids is higher than the adhesive force between the solid and the liquid. So you have to understand. So there is something as a cohesive force that is the same phase. So the liquid, one material will have cohesive force that will bind itself, and there will be adhesive force that will be the force of adhesion between the solid molecules and the liquid molecules. So what happens is when the surface tension is high, the cohesive force is higher than the adhesive force. But what happens is basically surfactants uh, reduce the cohesive force between the liquid material. So when it reduces the cohesive force, automatically surface tension will reduce. So that is how the surfactants work. Moving to question number five, ZNO is classified as a dash material as grown. ZNO is one of the group 2,4 semiconductors, N-type semiconductor, P-type semiconductor, thermal semiconductor, magnetic semiconductor. So basically, you get the hint from the question itself. So because it's a 2,4 semiconductor, it is an N-type semiconductor. So basically, um, when the doping material is boron, it is a p-type semiconductor, and when it is a nitrogen semiconductor, like nitrogen or oxygen is the doping material, it is a n-type semiconductor. You getting my point? So that is how it works. So moving to question number six, oxide nanoparticles are provi- uh, proved to have an excellent antimicrobial effect since their photocatalytic uh, properties dash with the potent antimicrobial activity and broad spectrum reactivity against many microbial pathogens, generate high thermal energy, generate vibrations that break the cell surface, generate free radicals, oxides and peroxidase, or generate acids. So basically, the answer here is generate free radicals and uh, peroxidase. So what will happen is visible light will fall on the titanium dioxide nanoparticles. So that will basically lead to generation of free radicals and will also create peroxide. So it will create hydrogen peroxide. So that hydrogen peroxide will actually put a oxidative stress on the cell wall membrane of the microbe. So this will lead to antimicrobial properties of the material. So that is how the titanium dioxide nanoparticle works. Okay, so next, DASH is a powerful imaging technique that can inform on the distribution of gadolinium within the tissue section with high resolution and sensitivity, electron microscopy, tomography, X-ray, synchrotron X-ray, fluorescence, spectroscopy. So uh, here, what we all know. So basically, even if you don't know what SXXRF is, SXXRF is so what you have to understand is gadolinium is basically used for fluorescence. It is a contrasting agent that is used in your biomedical application. So obviously, when it is a contrasting agent, you will obviously focus on the fluorescence. So in this um, uh, options only, SXRF is the only one which is working on the fluorescence of the material. So that is why the answer is SXRF. So that is a basic way. Obviously, you may know the answer. So this is a GK kind of question, but if you have to put a logic, that is how it works. So basically, what happens is you put a sample, you focus X-rays on the sample, and based on the X-rays, basically at every intensity of X-rays. So basically, what will happen is you will change the power of X-rays. So in XRD, what happens is in XRD, you change the angle. The intensity remains same. Here, basically, you change the intensity, and at every intensity, obviously, different atom will get excited. So what will happen is due to excitation, there will be fluorescence. That fluorescence is being detected by this detector, and based on that you are getting the spectrum. So that is how it is working. Okay, uh, so question number 8, scanning electron microscopy is combined with dash was used to determine the elemental composition of electron dense deposits on SEM, energy dispersive X-ray, TEM, XPS, cryomicroscopy. So the answer is energy. So the answer is energy dispersive X-ray photography. Moving to question number 9, antimicrobial efficacy of titanium dioxide nanoparticles may also be determined by cell wall complexity as they are more efficient against gram-negative bacteria which possess dash, while they are less efficient against gram-positive bacteria uh, and yeast species with dash. So basically, what this question wants to ask you is which kind of bacteria. So this is a even though the question is very big, what it is asking you is the difference between gram positive bacteria and the gram negative bacteria. So basically, the options are 3 layer, 4 layer, thicker cell wall, thinner cell wall, thinner cell wall, thicker cell wall, 2 layer, 1 layer. So the answer is thicker cell wall, thinner cell wall, and thicker cell wall. So this is how a gram negative bacteria cell wall looks like, and a gram positive bacteria cell wall looks like. So gram negative bacteria, you can see the cell wall is quite small, whereas in gram negative bacteria you have 2 layers of cell wall, and the membrane also quite thick. So basically, because of that, it becomes very difficult for the titanium dioxide to actually penetrate or break the gram negative bacteria cell wall. Question number 10, basically dash is a simple process in which water is passed through packed bed of solid absorption media filled in an absorption vessel or a column. Absorption, desorption, wetting. So the answer is adsorption. So here, basically, you have the answer given in the question itself. The bed of solid absorption media. So obviously, the process is an adsorption process. So, any questions regarding this assignment? Please unmute yourself and ask. Devrata sir, you have raised your hand. You can unmute and ask your questions.
Sir, from the week one,
Yes, sir.
the question was the rice is grown in Rabi season.
Yes, sir.
Then what will be the answer, sir? Right answer. We have already discussed before, sir.
Yeah, they have not reevaluated. So now basically sir has only started all the process. So you will get all your answers. So whatever assignment reevaluation regarding questions are there, no, all the questions have been. So now week 3 is going on for all the courses. So there we are going through one by one. So right now till week 3 they have started evaluating. So all the requests which have come from the students, they have been collated and NPTEL has sent to us. By tomorrow or day after tomorrow, basically, you will start getting the mails for reevaluated assignment and their answers.
Sir,
So
before Saturday also, no, sir?
yeah, before that, like before Thursday, by tomorrow is the deadline. So by Thursday, sir will release all the what do you say reevaluated assignment answers. So the process is going on. So because for another course, I am the internal TA for the one course. So for that I have already done for week 3 also. So all the requests, so because this course I think so there are a lot of wrong answers. The requests are also quite long. So we have to go through each of the requests. We have to also give the justification also. So it takes time, but you will get it by Wednesday, Thursday, because now they've started giving one after the other. You will get it by Saturday. That is for sure.
Saturday
Before
is
Saturday.
examination.
Saturday is an exam, na? So you will get it before that only, sir. Don't worry, sir. The
There was a question in the week for the contact angle of the water on oily surface is obtuse angle or acute angle or right
they
angle?
have given both obtuse and acute. So
Yes.
there are many questions they have given wrong. So we have raised that question, sir, with and the requests are getting collated and given by the NPTEL.
And in the week 6, there was a question. The cerium is denoted by.
What
There was
question? What is the
week
question,
6.
sir?
Week 6, number
Yeah,
1.
just a second.
Cerium is denoted by. There was
Cerium.
yes, sir.
Then
CE.
CE will be, yeah, CE will be
CE
done. Yeah, CE.
denoted by. So there was
Yeah.
58 CE 140, 58 CE 142. So how we can denote some in the two isotopes?
So you are so basically in that case you have to take with the isotope that is used in in the periodic table, whichever isotope is shown. So hydrogen has two isotopes, hydrogen and deuterium.
No, no,
But
no, sir. My question is that The
Uh,
question was the cerium is denoted by. Actually, cerium has the four isotopes.
yeah,
Uh,
exactly.
136, 138,
Yeah.
134, 140, and 142.
Yes, sir. Exactly.
But denoted by means in the periodic table, it is showing that 58 CE 140. But in the answer, it is showing the both.
I'll just check the question
Can you go
again.
to week
Yeah,
6?
yeah, yeah.
Week
I'm
6,
doing that only.
number
I'm
1.
going to do that only. Yeah, cerium is denoted by 142, 140, both A and C. This is a confusing question. Uh, yeah, this is a wrong question actually. Have you raised the question query in the panel, sir?
Yeah, I can raise, sir.
I
I
sure.
thought that I tell you, sir, today.
No, no, yeah, that we that obviously, but you should have raised in the question and answer forum also, because what happens is like coming from me, it will be like only I am having the problem. So you should always raise the question in the question and answer forum, and you have to you have to tell me. But main thing is raising the question in question and answer forum, else it will look like I am having the problem. So it should always come from, like, you should raise it and then I will escalate it. So that is how it will work. So you raise it in the question and answer forum, then I'll escalate it with your screenshot.
Yes, yes.
Okay.
And then what is the exact answer, sir? What
I
should be?
I think so. It will be the one which is
Actually, 58 140 is
in the
abundant.
periodic table.
Uh, no, no, it is
In the
abundant
periodic,
88%, and 142 is 12% only.
I think so. But based on the logic, no, even A and C is right. So uh, it is asking both the, if uh, they are asking no both the denotation. So in both of them, C is there. The for the like both are the isotopes of cerium only. So maybe you can put it as a right answer. So maybe you can consider this kind of questions as their logic might be, in their logic. This is the right question also. So one when I read it again, no, by their logic, this seems right what they have said. So they are used. See, obviously, maybe we may not set the question like this, but by with their logic, it is right, sir.
And in the week 6, question number 8,
Just a moment, sir.
the sperm can be preserved for
Preserve.
long duration
Yeah,
by vitrification and
cryopreservation.
cryopreservation. It may
Yes,
be
sir.
cryopreservation, but the
Uh,
answer showing the both.
both. Uh, Cryopreservation is the most popularly used method, but I think so. It might be. Just a second.
For sperm, sir, it always going for the cryopreservation.
Actually, sir, it is used. If you search on Google, no, it is used. It is a rapid freezing technique. So what it does is basically um, it like it is also a type of freezing technique only. It just basically converts sperm into a glass-like state to preserve that motility and DNA integrity. So basically, it is used. So if you, it might have not been showing the class notes, but on Google, if you check, both are there, sir. Because I had read about vitrification, so that's why I reconfirmed by searching on Google. Uh,
The vitrification is used for sperm or ovum, sir.
Sperm. On Google, it is showing sperm. Uh, uh, Earlier, it's not a very famous procedure, but it is there because I had read about it. That's why I
Yes,
had.
yes. And for long time it is also used.
No, I think so.
Long duration. It is a maybe a short duration for vitrification.
So basically, what they are saying is cryopreservation. was has lower, like after you thaw it, post thaw motility of cryo is lower. So with vitrification, you are getting higher motility after thawing in vitrification. That is why we are using vitrification. So this is a new technique, and it is used because the post thaw motility is higher in vitrification.
Then the
So
answer will be both.
both. The answer is correct here.
Okay, sir.
Anyone has any other questions? Please list them so that we can finish your doubts, and maybe you can go and study for the exam. Debrata sir, whatever questions you have, you can ask. Yes, Kashish ma'am. You can ask, unmute and ask your questions, ma'am. If you don't have any question, you are free to leave the session. Yes, Kashish ma'am. You can ask.
So
Yeah, you can
I'm
leave. Yeah, yeah. Yes, Kashish ma'am, please.
also actually I was asking about the slides which you were teaching in previous sessions, like these slides which you was teaching us right now. Can we get those questions so we can
Yeah,
study
they
for
are
it?
there. They are there. I'll just show you how to do it. So just
Okay, sir.
I'll just present my entire screen. I guess that will be easier for you to find. So this is I hope you are able to see my screen. You can see the Swam portal now.
Yes, sir.
So you go to my courses, go to course. So you go here. So problem solving sessions. Your problem solving session recordings. You're following. So you click here. This sheet will open. So once the sheet opens, here is the YouTube link of all the videos. But I would not suggest you going through it. Just go here. You'll There will be a drive folder that will open, and all the PPTs will be here. Okay. So I'll complete all the PPTs, yesterday's PPT and today's PPT and week 5 PPT tomorrow, and tomorrow I'll close everything. So by tomorrow morning 10 you will get everything, all the lectures and all the slides.
Okay, sir. Thank you.
Okay. If you don't have any questions, you are free to leave the session. We'll just be taking the doubts now. So yeah. So Rakshita has asked the question how to prepare mainly now. So considering you don't have much time for the exam, so what I would suggest is go through the notes, the PDF notes which sir has given. Uh, Go through the slides which are there in the drive, and go through this year's assignment answers. I think so this that is more than enough. Yesterday I also gave the important topics. I'll repeat them once again. One is the species, where the wheat species from, like a potato is native of dash, and those kind of questions will come. Second, nanomaterial synthesis methods like the sol gel method, ball milling method. What kind of method is it? It is a top down, bottom up method, or whether it is a mechanical method, chemical method. That kind of questions you can ask, expect. Then the third kind of question, third main important topic is zero dimensional, one dimensional, three dimensional nanomaterials. So you can expect questions from these. And like gadolinium, obviously there'll be a lot of questions for medical application, medical imaging kind of questions. Then last but not the least will be the characterization method, like the SEM, TEM, XRD, XRF, those kind of questions. So these are the main questions. These are the main topics you need to be very thorough with. You should know all the short form, what to say, full forms of the short forms. So what is XRD, what is FTIR, what is EDS, what is SEM, what is like uh, the characterization technique. You should know the full form. You should know what it is used for what. So SEM is an imaging technique. XRD is used for finding the crystal structure or elemental like elemental composition. Sorry, this EDS is used for elemental mapping. FTIR is used for functional groups. So these kind of things you should know very well. You should know, understand what each characterization technique does, what is used basically. So like obviously there every characterization technique can be used in detail, but what is the basic use of those characterization technique you need to do. And I think so that's it. um, and basically use your common sense, because as I showed you even today, sometimes if the question seems to be too difficult, the answer is there in your question itself. So please be mindful of that. I think so. This should be a strategy till Saturday, and you will get good marks. You should at least get 70, 80. I think so. I am expecting everyone get at least 80. So let's see. All the best. If you have any doubts, you can put in the chat box. So Sakshi has asked, "Hi, can you please break down the uh, format of the exam and marking scheme of each question?" So basically, it will be more or less. It depends. Every exam, every NPTEL subject depends. So maybe you can expect 50 questions is what the standard is. So it will be 50 questions, and there is no negative marking. So that way you are safe. You can, if you don't know something, you can take a chance. And mainly it will be MCQ. There might be MSQs, but I'm more or less expecting only MCQs in this topic, in this question, in this exam. So MCQs, 50 MCQs. That's it. One mark each. Or even if they give 50 MCQs 2 mark each, the weightage will be the same, because anyway it will get scaled down to 50 only. So whether it is 50 mark paper for with 50 questions, or 50 questions for 100 marks, the weightage is going to be the same. It will get divided by 2, and then that will be counted in your exam. So this is the general scheme. I'm told you. I have also given you the important questions. If you have any questions, you can put in the chat box. Uh, so yeah, Sakshi is asking if there will be any essay type of question. So no. So what happens is essay type of questions are given only when there has been at least one assignment which was subjective. So your course never had any subjective questions. So there is a very less chance. I'm not saying there is no chance. NPTEL can surprise you, but there is a very less chance that you will get essay type of questions. Like the chances like 1 or 2%. That can happen only if NPTEL is insisting the faculty to do it. But more or less, if you don't have any subjective assignment, they don't do it. So there is very less chance. I would say don't worry about essay type of questions. Just focus on the MCQ. Okay. So if you don't have any question, you are free to leave the session. All the PPTs will I have shown you how you can access them. The your current thing will be PDF, search PDF, the PPTs of the sessions, assignments, and the important topics which I have told you. So If you don't have any question, you are free to leave the session. I won't keep you waiting. Anyone has any other questions?
Yeah, sir, extremely sorry, sir. Actually, I'm not able to locate the drive file. So, as you said, take screenshots. I'm so sorry, sir.
Should I share it again? Should I show it again? Else
Yeah,
I'll
sir, please,
share
sir.
the drive link only, no, in the chat box. Just I'll share the drive link. Just a moment.
Yeah, yeah, thank you, sir.
What I'm doing is I'm sharing the drive link. I've shared the link. You can check there.
Okay, sir. Thank you.
Yeah. Ma'am, you have any questions, ma'am? But do you have any questions? If not, maybe you can focus your time on revising for the exam. Do you want so steady stabilization is usually imparted by dash uh, example cellulose derivatives, polyhexamers, polysorbates, and povidones, preventing particles from getting into the range of attractive Enderle-Wells forces. Non-ionic polymers and non-ionic surfactants, ionic polymers and non-ionic surfactants, ionic polymers and ionic surfactants. So you want to keep the two nanoparticles separated from each other. So basically, you will not allow the bonding. So there is no whenever there is no bonding. So to do that, you reduce the cha- uh, charge distribution. You try to Yeah, hello. Yeah, Khyati Inni. So basically, it's a good question. So you don't actually need to refer any books for the exam. All you need to do is basically go through the uh, PPTs, not PPTs per se, but go through the videos, go through the PDF of the lectures, and go through the previous year and this year assignment. Previous year assignment uh, are there in this what you can say. Previous year assignment are the ones the website are the ones which I'm taking. You can find the link here, and for current year assignments, you can get into your so previous you can get through the Google Drive, and in this year assignment you can access here. Previous year question paper is a secret. You will not get it. It's not possible to get it. So you have to rely mainly on the assignment questions this year and previous year, and maybe you can focus on the um, lecture notes. Uh, Coming to the book question, so for this you don't need any book for this course. If you go for any book, so if you want to go for like depend because nanotechnology is a vast subject. So if you want to go into MEMS or NEMS, you have to go with Mark J. Meadow. For core nanotechnology, I don't remember the book, but maybe you can check some MIT courseware or something. Over there, you will get the important how to score. So yeah, how to. So basically, 80% will be very easy. Like you will be able to do it. For 90%, you will have to go thoroughly through each and every video and each and every class note, uh, and maybe keep yourself updated also. But you will easily get 80%. So getting 90%, obviously, you will have to go through each and every lecture and go through it thoroughly. So that is the trick to get above 90%. 80% anyone can get, even if you like just with basic effort, you will get easily. Any other questions? So some of the questions are not from the lectures. They are like general kind of questions, but in terms of in your final exams, you can expect less of those questions because they will be like you can if it is outside the lecture scope, or if you think it is outside the syllabus, you can raise the query after the exam is done. You can say that these questions were from outside the syllabus, so you can do that. So you can do that for your so you can expect less of these those kind of things in your final exam. Whatever happened in the assignment, that is because you have the access to Google while you're doing your assignment. So these kind of questions are asked in your assignment. Okay, thank you. If you don't have any question, you're free to leave the session. I'm just waiting, keeping the floor open for anybody has. Yeah, one more out. Yeah, please. You can ask your doubt, please.
Good evening, sir.
Yeah,
So, can you just show me the question, sir?
This today's questions, yeah, sure.
Yeah, yes, sir.
Yeah, I will just race through them. So today's questions were very easy. So the first question is here. Steric stabilizers are usually imparted by uh, stabilization is usually imparted by dash. Example: cellulose derivatives, polyhexamers, polysorbates, and polyvidones, preventing the particles from getting into the region of attractive van der Waals forces. So the answer is basically non-ionic polymers and non-ionic surfactants. So why we are doing it? Basically, what happens is because of the nanoparticle, the charge is formed on the surface. As we say, as we already know, the since the atoms are very closely packed together, the charge comes on the surface, the electron charge, and then to balance that charge, the electronic double layer is formed due to the ionic surfactant. So basically, what you want to do is you want to keep the two nanoparticles separate so that there is no interaction between the two nanoparticles. So that is why what you do is you reduce the charge distribution in the medium, and that leads to uh, better stability of the nanoparticles, and that is achieved by using non-ionic polymers and non-ionic surfactants. Question number two: to prevent the toxic effects of gadolinium while keeping its dash, the gadolinium ion is chelated or encapsulated by a ligand uh, to form an entity called a complex or a chelate. Diamagnetic properties, ferromagnetic properties, paramagnetic properties, soft magnetic properties. The thing is, this is asking you what kind of magnetic behavior gadolinium shows. It shows paramagnetic properties because, as we studied last time, it has seven unpaired electrons in the 4f orbital. So, because of that, it shows paramagnetic properties. Um, so,
Sir?
in the yeah.
Yeah. So the previous questions, so they are not discussed about in during the lecture time. So how did you get this questions?
This was asked in the previous year. I don't
Okay.
know whether it was discussed. So whatever I am doing now, I'll show you. I have access to last year's
Okay,
question
sir.
papers,
Yeah, yeah.
and from that I'm showing. That is my job to do it. Is
Okay,
that
sir.
just take the previous year question and show how what just give an explanation. So next time when it will be there, I will be showing this year's question. So that is how that is what
Okay,
my job
okay, sir.
is. So
Yeah, thank you. Thank you, sir. Thank you so much.
so. Um, so I hope you are the third question is done. So the third question they are asking, in drug industry the commonly used steric stabilizers include hydroxypropyl methyl cellulose, propyl cellulose, PVP, methyl cellulose, HEC. So the answer is basically all of them, HPMC, HPC, PVP, MC, HEC. All of them are used. You can find these names at the end of your at the, behind on your drug label. So any medicine you buy, you will find these names. Moving to the fourth question, dash compounds lower the surface tension and enable the proper weighting of the drug particle with suspension liquid, usually water, stabilizers, surfactants, gelling agents, milling agents. So basically, what happens is surface tension is basically a cohesion between between the molecules. So what happens is there is a cohesive force that is between the molecules of the same material. So if it is oil, all the oil molecules will be bonded by the cohesive force, and when you immerse the oil on uh, in your container, basically there will be interaction between the oil molecules and the container, the whatever the glass molecules. So the force that is acting between the oil and the glass molecule is called as the adhesive force. So what do surfactants do? Is surfactants reduce the cohesive force between the molecules. So basically, because it reduces the cohesive force, obviously the surface tension reduces, and it is able to disperse properly in the suspension. Um, so question number five, ZNO is classified as a dash material as grown. ZNO is one of the group 2,4 semiconductor material. So the answer is N-type semiconductor. Uh, so basically we all know. So if it is a boron or boron doping, boron germanium, those dopant, it is a p-type semiconductor. If it is a nitrogen group, in group doping, it is a n-type semiconductor. So here there is since the 2,4 semiconductor, it is a n-type semiconductor. Then moving to question number 6, titanium dioxide nanoparticles also proved to have excellent antimicrobial effects since there is a photocatalytic properties, potent antimicrobial activity, and broad reactivity against many microbial pathogens, generate high thermal energy, generate vibrations that break cell surfaces, generate radical oxides and peroxides, generate acids. So the answer is generate radical oxides and peroxides. So this is how it works. So when the visible light is absorbed by the titanium dioxide molecule, there is excitation happening that generates free radicals as well as hydrogen peroxides. These peroxides create oxidative stresses on the bacteria, and this gives the antimicrobial properties. So that is how it works. In the question number 7 is dash is a powerful imaging technique which that can inform on the distribution of gadolinium within a tissue section with high resolution and sensitivity. So the answer is synchrotron X-ray fluorescence microscopy. So how it works is basically what happens is you put X-rays with different intensity or different power. Uh, Based on that, you will get a spectrum, and then that spectrum is correlated with the reference library, and you are able to identify the material. So since the you are getting fluorescence here, uh, it is called as the for gadolinium it is quite widely used. So because gadolinium is a fluorescence kind of, it's a contrasting agent, so that is why it is XRF is widely used in this. So the question number 8. SM, that is scanning electron microscopy, is combined with dash, was also used to determine the elemental composition of electron dense deposits on SEM. So EDS, that is energy dispersive X-ray, TEM, XPS, and cryomicroscopy. So the answer is energy dispersive X-ray. So what it does is basically when you are using a SEM, whatever the backscattered electron, there will be backscattered electrons, and there will be the spectra will be generated, the X-ray will be generated. So based on the X-ray that is generated, it is detecting the elemental composition of the material. The question number 9, antimicrobial efficacy of titanium dioxide nanoparticles may be determined by cell wall complexity, as they are more efficient against gram-negative bacteria, which possesses a dash, while they are less efficient against gram-positive bacteria and yeast species with. So basically, it is trying to ask you what is the how is the cell wall of gram-positive bacteria and gram-negative bacteria. So here you can see the gram-negative bacteria, the cell wall is quite big, whereas in the gram-negative bacteria, the cell wall, you have two cell walls. That is, there is an outer cell wall and an inner cell wall, but the cell wall is quite small in gram-negative bacteria. So in gram-negative cell wall, it is a thinner cell wall, and gram-positive bacteria, it is a thicker cell wall. Moving to the last question. Basically, this is a throwaway question, but it is not formulated properly, but still we have to solve it. Dash is a simple process in which water is passed through a packed bed of solid adsorption media filled in an adsorption vessel or a column. So the answer is adsorption. It is an adsorption process. Any questions? If you don't have any question, you are free to leave the session. All the best for your exams. Hope you do well.
Good evening, sir.
Yeah. So good evening, Madhumita. As I said earlier as well. So the thing is, you don't need any books for the exam. Books are of books are you don't have the time to actually refer to any books. So for the exam point of view, you only have to focus on the notes which sir has given, the previous year assignment and this year assignment. um, like you don't wander around right now because right now you don't have the time to do it. There are various amazing books on nanotechnology written. Nanotechnology is a evolving field, and you can do it. But from the exam point of view, the stick to the source video, source note, this year assignment, previous year assignment, which I've provided on the using the drive link. I'll share the drive link again in the chat box. You can use that again, but that's it. Like, don't wander right now. You don't have the time to do it. This is you just have like 5 days. Again, you will be doing some many people will be doing with their full-time college or full-time job, so you don't have the time. So don't waste your time on finding the books and all those things. Just these important things. If you are even more short on time, the important topics are I have listed them again yesterday also. I'll list them again. Preparation, nanomaterial preparation techniques, characterization technique, that the preparation techniques are the soldier technique, ball milling, and all those things. Then the characterization techniques, M, XRD, FTIR, those things. Then the next thing, the gadolinium. So on that, a lot of questions can be asked. Then biomedical applications of nanotechnology, those kind of questions. Then 0D, 1D, 2D, 3D nanomaterials, and the origin of the species. So potato is native of this, sugar is native of that, like those kind of questions. So these are the important questions. If you are very short of time, only do this. If you have enough time, if you want to score more, I've told you source notes, source videos, previous year assignment, that is I've shared the link, and this year assignment. That's it. Any questions? Okay, so if you don't have any question, you're free to leave the session. I won't hold you back. There are just 5 days left for the exam. All the best. Hope you do well. considering there is nobody there, we will bring the session to close. I'd like to thank each and every one of you all for your participation and your contribution. Thank you, everyone. I wish you all the best for your exams, and I hope I wish you well in your future endeavors. Thank you.